Universal law of gravitation. Isaac Newton stated the universal law of gravitation, therefore, it is also known as Newton's law of gravitation. Questions in front of the Newton were: if the planets are orbiting the Sun, what force is keeping them in orbit? What force keeps the Moon in its orbit around the Earth? Could the force of gravity be universal? The apple was attracted to the earth. All the objects in the universe were attracted to each other in the same way the apple was attracted to the earth. When objects are released near the surface of earth, they always fall down to the ground because of gravitational force exerted by earth. Galileo pointed out that heavy or light objects, when released from the same height, fall towards the earth at the same speed, that is, they have the same accelerations. Newton went beyond and proposed that the force of attraction between the masses is universal, and he stated the universal law of gravitation, that is, F is directly proportional to product of their masses and inversely proportional to square of distance between them. Before generalizing and stating the universal law of gravitation, Newton first studied the motion of moon around the earth, and the known facts about the moon were: the period of revolution of moon around the earth is 27.3 days. Distance between the center of earth and moon, that is small r, is 3.85 into 10 raised to 5 kilometer. Moon revolves with the constant angular velocity omega in the circular orbit around the earth. Therefore, the required centripetal force for the moon to maintain the circular motion around the earth is given by F is equal to mr omega square, equation number 1. From Newton's second law of motion, we can write F is equal to ma, equation number 2. From both the equations, equation 1 and equation 2, we get ma is equal to mr omega square. Here m on both the sides will get cancelled. Therefore, we can write a is equal to r omega square. This is equation number 3. But omega, constant angular velocity, can be written in terms of period of revolution of moon. Omega is equal to 2 pi upon t. Substituting omega in equation 3, equation 3 becomes a is equal to r into bracket 2 pi t, 2 pi upon t bracket square. Substituting values of r and t, we get a is equal to, in bracket, 3.85 into 10 raised to 5 multiplied by 10 raised to 3 into 4 pi square divided by 27 into 24 into 60 into 60 bracket square. Here the r is given in kilometer. If we multiply it by 10 raised to 3, it will get converted into meter. And the capital T is here 27.3 days. Multiply it by 24 into 60 into 60, then it will get converted into second. After calculating this step, acceleration is equal to 0.0027 meter per second square. This acceleration of moon directed towards the center of earth, and this much smaller, or this is the much smaller than acceleration felt by body near surface of earth, that is g is equal to 9.8 meter per second square. The ratio of acceleration of object to acceleration of moon is equal to 9.8 divided by 0.0027. This is approximately equal to 3600. This is equation number 4. Also, the ratio of distance of moon from earth surface to distance of object from earth surface is equal to 3.85 into 10 raised to 5 kilometer divided by 6378 kilometer. Here the distance of object from center of earth is approximately equal to radius of earth, that is 6378 kilometer, and this is equal to 60, equation number 5. Thus from the equation 4 and 5 we get the ratio of acceleration of object to acceleration of moon is equal to, in square bracket, distance of moon divided by distance of object bracket square. This is equation number 6. Therefore the acceleration of object is inversely proportional to square of distance of object from center of earth, that is acceleration a is direct, that is a is inversely proportional to square of distance. As F is equal to mass into acceleration, therefore using equation 7, force exerted by earth on the object of mass small m at a distance r is given by F is directly proportional to small m and inversely proportional to r square. Similarly, an object also exerts a force on earth which is Fe is directly proportional to capital M, that is mass of earth, and inversely proportional to r square. According to Newton's third law of motion, both these forces, that is the force exerted by earth on object, that is F, and force exerted on the earth by the object, that is Fe, both are equal in magnitude and opposite in direction. Therefore Newton concluded that force also proportional to mass of earth. Therefore gravitational force between earth and an object of mass m is given by F is directly proportional to product of their masses and inversely proportional to r square. Statement of the Newton's law of gravitation. From the above conclusion, the Newton concluded that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to square of distance between them. Here m1 and m2 are the two masses separated by distance r. Both the particles or both the masses will attract with each other with the force which is equal but opposite in direction, and therefore the force of attraction between them is given by capital G into m1 m2 divided by r square, where here G is universal gravitational constant. The force that mass 1 exerts on the mass 2 is given by vector F21, and the force that exerted by mass 2 on the mass 1 is given by vector F12. Both the forces are equal but opposite in direction. Therefore the forces forms the Newton's third law, that is action-reaction pair. This force is always attractive in nature. The gravitational force exerted by uniform sphere on a particle outside the sphere is the same as the force exerted if the entire mass of the sphere were concentrated on its center. The Newton's law of gravitation is universal in nature, and this universal law is known as inverse square law. The value of acceleration, or the value of universal gravitational constant G, capital G, is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. The dimension of universal gravitational constant capital G is 3 in length minus 1 in mass minus 2 in time. In the vector notation, Newton's law of gravitation is written as follows. Vector F12 is equal to minus capital G into m1 m2 divided by r21 square into r21 cap. Here the m1 and m2 are the masses of two objects separated by distance r, and capital G is universal gravitational constant, and R21 cap is the unit vector in the direction of vector R21. Gravitational force due to collection of masses. For collection of the point masses, the force on any one of them is the vector sum of gravitational forces exerted by all the other point masses. Here we consider the system of masses or collection of the masses m1, m2, m3 and m4. Then the resultant force acting on the mass m1 is given by vector f1 is equal to sum of the force vector f12, vector f13, vector f14 that are exerted by all the other three masses. Therefore, vector f1 is equal to vector f12 plus vector f13 plus vector f14. These are the forces exerted by mass m2, m4 and m3 on m1 individually. For n particles, forces on ith mass is given by vector fi is equal to summation over vector fij from j is equal to 1 such that j is not equal to I up to n, where Fij is the force on ith particle due to jth particle. Next point, acceleration due to gravity. If capital M is mass of the earth, small m is mass of point object, small r is distance of object from center of earth, then the force of attraction between them, point object and earth, is given by F is equal to capital G into capital M into small m divided by r square. This is equation 1. If the point object is not acted upon by any other force, it will be accelerated towards the center of earth under the action of this force. Its acceleration can be calculated by using Newton's second law, F is equal to ma, equation number 2. From equation 1 and equation 2, we can write ma is equal to gmm divided by r square. M and this small m on both the sides will get cancelled. Therefore, acceleration due to gravity of the earth is equal to g into capital M upon r square. This is equation 3. And this acceleration due to gravity of earth is denoted by small g. If object is close to the surface of earth, that is small r is approximately equal to capital R, therefore radius of the earth, then the acceleration due to gravity on earth surface, g earth surface, is equal to capital Gm divided by r square. The value of small g depends only on properties of the earth and does not depends on mass of the object. This is the relation between small g and capital G, that is acceleration due to gravity and universal gravitational constant.